All right, everybody. This is our lecture for, let's see, 5/2/19, lecture, etc. And perhaps you have noticed my illustration here. I am aware that we are in here. Okay? Lots of people in the Forster household are in here. Lots of people in our chemistry class are in here. Lots of people in the school and even in the administration and teachers are in here. All right. And even this illustration is actually a meta commentary because it itself needs a lot of help. But I guess we just want to know, I want y'all to know that I'm aware that we're here, and we just need to kind of all work together and push on through. Okay, so we don't actually have to get off of the struggle bus here, but we do need to work hard to minimize its effects on us. All right. So I just want to have a word of sympathy there and exhortation to do well for a little bit longer, and then you can relax in the summer knowing that you have, in fact, done really well. Okay? So with that being said, number one, just check it off. All right, so what we're going to do, I'm going to finish the lecture for Chapter 11. I'm going to work some of your homework. I'm going to review the scope of the test material, and then I'll tell you what the plan is for the rest of the year so you can be thinking about that. Okay? So the only thing we haven't covered is kind of really the last little bit right here on titration. Okay? And much, to my constant chagrin, we don't have a super awesome chemistry lab, and it would really be pushing my limit of knowledge to use it anyway. And so we are just going to use some definitional stuff here, and that is how this stuff will be tested, not any really functional knowledge of how to do it, okay? How to do any of this stuff. So let me get us set up right here, and let's go through what we've got going on in the end of the chapter here, all right? So we need to know, and by we I mean you need to know for the test, what a pH indicator is. And clearly we can see it's this is page 312, excuse me. Substance that changes color in solutions of different pH. Guess what? Its pH indicator indicates pH. All right? We need to know that litmus paper is one such indicator. Okay? Just a little straighter here. Okay? Litmus is one such indicator. And I think it is good to know that a natural pH indicator is the juice from red cabbage. Okay? And super cool when my nerdy parents set me up eternally for a nerdy life. We actually did something where we cut up red cabbage, we boiled it, and then we soaked the strips of paper in it, and we actually did pH stuff. The Forster children have never done something so cool as that. I don't think. Not at home, anyway. But, so, anyway, just need to know that. Litmus, red cabbage juice are two natural pH indicators. All right. And, yeah, so that's pretty much that. Then we've got this over here on our other page. You need to know what a standard solution is, okay? And that is an acid of precisely known concentration called a standard solution. So that's what it is, an acid of precisely known concentration It's gradually added to a base of unknown concentration. All right, and so what they're doing is, this is almost sort of like the control in an experiment. Okay, we know what this one is, and so we're going to use that one to measure something else. Okay, and it's actually not like much like a control. It's like a measuring device, or like a ruler or something like that. So we know what it is. We know that that thing is exactly 1 centimeter, and so we're going to use it to measure other things. So we've got a precisely known acid solution, and it's added to a base of unknown concentration, or vice versa. Okay, so it's a solution, I guess more broadly we would say, of known concentration. Okay, so if you go to like a lab supply store or whatever, I guess maybe go online now and go to a lab supply website, you'd be able to order 10 molar sodium hydroxide, right? So you would know that in every liter, there's exactly 10 moles of sodium hydroxide. And so that means that straight out of the jar, you can use that to measure the acidity or basicity of another solution that you don't know what its pH is. Okay, so we basically have to use a liquid indicator, and what it does is, as you add that drip, drip, drip acid into the base, or vice versa, that pH starts to come down, okay, because you're adding a very low pH liquid into a high pH liquid. And at some point, let's see, so look, right here, okay, so right here, what it does is it changes very slowly for a long while, and then all of a sudden, bam, it drops. Now this is not perfectly straight up and down, it's slightly to the side, okay? But right here, that indicator will change, okay? And you'll know by how much you had to add to move that solution to this point what the concentration of the unknown solution is, okay? All that to say, you need to know that titration, where did we define titration? All right, sorry, I had to pause you guys there for a second. The struggle bus had a couple of backfires, and needed to keep that off camera, as it were. All right, so we need to know a couple of things here. You know, an equivalence point is the endpoint. And these will just be tested as vocab, okay? And so let's read together just right here what's going on here. You remember that? All right, so we had this this graph. It's one on this page right here, 316. So flip over there. We have equivalence point and endpoint. All right, an equivalence point is the point where chemically equivalent amounts of acid and base are present in the solution. So basically it's been neutralized, okay? And you can see the pH right here, right at 7, which is what we would expect if it's completely neutralized. Okay, all the acid is mixed with all the base, and it's been all formed to water and a salt, which in theory is perfectly neutral. Okay, we're not getting into any more complexity than that. Don't know a whole lot of it offhand myself, and don't feel like I could explain it any better than he has in the chapter here, which I'm sure you guys have already read and annotated and knew I was going to hit these points anyway here. Okay, indicator changes color at a point called the endpoint, and which we use it as an approximation for the equivalence point. So literally, you need to know that the endpoint is an approximation for the equivalence point. Okay, and that the equivalence point is the point where they are essentially balance between acid and base. Okay, make a note card, do whatever you need to do. It's going to show up on a test. Okay, so at this point we've got these two. We've got standard solution. We've got, you need to know what a pH indicator is. You need to know what litmus and what red cab. Know that those are two pH indicators there. Okay. I recommend that you just read through this stuff on this page. I can't say that I'm going to do a whole lot of testing on that because it's a pretty specific topic, and to be honest, I'm not quite sure why he spends so much time on it when it's a very sort of rigorous lab technique that's pretty advanced. So anyway, yeah, I think that is basically all I need y'all to know. Okay, so a little bit of background on titration so you know what it is and what it's for. And with that, we have finished the lecture. Okay. All right, so let's dig into some homework. Make sure we've covered all of the problem working techniques so that you guys have got that. By the way, this is Elsa Gray. Extremely cute. All right, so let's look at some examples from 28. All right, I recommend you get your homework out, and I recommend that you follow along, correct how you did it, right or wrong, and let's get going. All right, so if we look at A here, all we're trying to do is note whether it's acidic, basic, or neutral. Okay. We've got a couple of approaches we're going to engage to do this. All right, and I recommend always looking at the pH or pOH if we can. All right, so for this guy, how will we, sorry, let me rearrange a little bit here. How will we do this? All right, how do we get from this to this to this? All right, so we have to remember that to get from here to here, pOH is equal to the negative log of OH minus, and that is equal to negative log of 1 times 10 to the negative fourth. Okay, if I drop this during the problems, know that it's assumed and it doesn't change the value, so I could have written just 10 to the negative fourth in those. Okay, and literally, we're just going to take that and we're going to say 10 negative fourth, sorry, 1 times 10 to the negative fourth, which is what that shorthand there means. You see that? I feel like this is not showing up very well. There we go. All right, so you see that? Boom, and that's 4. Okay, now this is our pOH. That doesn't help us in figuring out whether it's acidic or basic. I mean, it could if you knew what those relationships were. To me, pH is easier to remember, and so just go ahead and say pH plus pOH is always equal to what? 14. Good. Glad you guys remembered that. All right, so now we say pH plus 4 is equal to 14 equals 10. So pH equals 10. Okay? And so then we can say this is basic because pH greater than 7 equals basic. Right? All right, follow along. If you don't follow along, it just means you're not familiar enough with it, and that means you need to be studying all of these, okay? because you have this in your homework and I'm currently explaining it, this is all fair game for the test. Okay? So don't be surprised if something very similar to this shows up on the test. Okay? So prepare. Be ready to work it. Alright? B here. I'm trying to do this kind of awkward place on the page here. I can't really. Let me go up. There we go. Alright, so. Alright, H3O plus. How do we get to pH? We just take the negative log of that. So negative log of 10 to the negative 6th. Okay, we know that's going to go to 6. We can put it in the calculator, and I recommend that you do. But if I plug that in the calculator, it's just going to spit out 6 equals pH. And what is that? Less than 7, so it's acidic. Straightforward. C is going to be a pH of 9. You can plug that in your calculator. Negative log of this number right here. It's going to be 9, so it's going to be basic. Okay, so these are not simple. The only tricky thing is that when you're given an OH concentration, that's going to spit out a POH. Okay, and then you have to do this deal equals 14. Okay, don't forget to do it. I can't. There's no simpler way to break that down. Okay, so just go through it, work problems, do what you need to do to make sure you can work those on the test. Okay. All right. What is this one? If these are exactly equal, that means it's totally neutral. pH of 7 equals that. Okay. And we could check that out and say, if this and this have to equal 14, what do they both have to be? It's got to be set, or the logs of them have got to be 7 and 7. So it's got to be perfectly neutral. Less than 7, acidic. All right. H3O plus is less than OH minus. That means that it's basic. We don't know about how much. We just know that it's not balanced, and it's balanced in favor of the OH minus, which means it's a basic solution. G, POH, read carefully. POH plus pH equals 14. Again, obviously you could figure out what the pattern is, but I prefer to look at pH. So pH is going to be equal to what? 9.09, which is basic. Okay? All right. Lastly, this is identical to the first one. O, except for look, when we take the negative log of 10 to the negative 7th, put that in our calculator, it's going to equal 7, so it is neutral. Okay? All right. Good deal. Rolling on. 31. All right. How are we going to calculate this? Okay. This is, we need to figure out, we need to get to this. Right? That's what's going to tell us our actual pH when we take the negative log of that. All right, so how are we going to get from here to there? Well, basically this is testing, do you know how many of these is going to come out right here? Okay, so if this is molar, we can say that that's going to create, each one of those is going to give up one hydrogen, so that's a 1-to-1 kind of mole ratio there. So our concentration is going to be 1.56 times 10 to the negative third for our concentration of H3O plus. We can take the negative log of that. Okay, so we need to be looking at how many ions each one of them creates, and we'll see one that's got 2 here in just a second. Okay, but it's pretty straightforward, so we're going to say negative log of 1.56. And if it's better for you to do this, then just do it. Times 10 to the negative third. Close your parentheses. 2.8. Okay, so when this number is not just a 1, you can't just pull that number down. It's not going to be an even 3, but it's going to be pretty close. All right, so 2.81. So pH equals 2.81. Okay. What about the OA? Excuse me. What about the oh, I'm sorry, man. Yikes. So I didn't read my instructions. Ah, foolish. Okay. So sorry. The actual answer is 1.56 times 10 to the negative third. That's it. So 1 to 1. All right. So how do we get to this then? The concentration of OH? Well, because concentration of H3O plus times the concentration of OH minus equals what? 1 times 10 to the negative 14th in an aqueous solution of water. Right? Plug this in for here. 1.56 times 10 to the negative third times x is equal to 1 times 10 to the negative 14th. So we will just put that in the calculator here. Okay? And so we will say 1, let's do open parentheses, 1 times 10 to the negative 14 divided by open parentheses, 1 dot, put everything in parentheses, times 10 to the negative third. Okay, and we're going to have concentration, so X is equal to the concentration of OH minus, which is equal to 6.4 times 10 to the negative 12. Okay. Well, and let me check my answers here to make sure I'm not doing something unutterably dumb, because it's been known to happen in the past. 1.56 times 10 to the negative third, boom, and 6.4 times 10 to the negative 12, boom. Okay, straightforward on that as long as you read the instructions. So just be careful. Make sure you're noting what's being asked for. Okay, you probably will figure it out eventually, just like I did, but you would have done extra work by that point. All right, so let's look at B. All right, so what's going to happen here? This SrOH2 is going to go to what? Sr plus, or excuse me, Sr2 plus and 2 OH minuses. Okay, so that means if I've got 0.011 molar here, what's going to happen? We've got a 1 to 2, so that's going to go to a 0.022 molar solution of OH minus concentration in the solution. Okay, so be on guard for that. This is going to donate 2 OHs. All right, so the concentration of OH minus is going to be equal to 0.022 molar. And so how do we get to H3O plus? Question mark. Well, again, H3O plus times OH minus equals 1 times 10 to the negative 14th. Plug in 0.022. And so then we will just edit our formula from before. So 1 times 10 to the negative 14th. I'm sorry, this is so rough on seeing it here. I don't know why light makes it look like that. All right, divided by what? 0.022. Let's see. Delete. Okay. Oh. Okay. So 4.5 times 10 to the negative 13th. Okay. So we can see that's our H3O plus concentration. All right. We can see it's going to have a super high pH. Okay. We can see it's going to be somewhere between 13 and 12, maybe? Yeah, I think that's right. 12, but somewhere between 12 and 13. That's pretty basic, right? All right, continuing on, we would work. How would we do this? How do we get to the 2.5 molar? Okay, 2.5 molar. And so that concentration, this is NaOH, it's just going to donate 1. Okay, it's just going to donate 1. So that's going to be equal to OH minus concentration, which is equal to 2.5. And that's that. And then we see that 2.5 times the H3O plus equal to 1 times 10 to the negative 14th. Divide that across, and whatever you get is your concentration. Okay? And you'll see that, well, I'll actually just do that here. 10 to the negative 14 divided by 2.5. It's actually 4 times 10 to the negative 15th. But you'll see that's actually going to give you a pH above 14. So that's a super duper strong base. Okay? And so, you know, just kind of one of the basic takeaways from some of this is that, like, you can take an NaOH solution and it can have a pH, it's always going to be greater than 7 because the only thing you can do is add OHs, right? It's going to be greater than 7, but it could go from 7.01, say, all the way up to 14 plus, okay, pH. So don't think of like this compound as having a certain pH because it's only concerned with concentration. It's not concerned about what is causing that concentration to change. Okay? All right. All right, so you guys get the deal. We got to get moving here. So 8.9, we plug that in for the H3O plus. That would be our answer for this one. That's literally the same number here, and then the OH minus would be set up this equation again, except we have that in for the H3O plus. Okay. If you got time, pause and work that out. Do whatever you need to do. All right. So how do we approach some of these? Oh, more algebraic numbers. So sweet. All right. What do we got going on here? pH and pOH. How do we do that? So we need pH is what? Negative log of H3O plus. pOH is equal to negative log of OH minus concentration. Focus y'all here, sorry. Okay. All right, so we just got to see what we're given, and these are going to be our 3. Okay, and these are the suggestion, you know, well, we're not going to use it here, but I would suggest that you are able to write this from memory. Okay, these are the 4 things you need to know. With those, you can solve any of these problems. Okay, so what do you need to know here? You need to know that the concentration of NaOH is 0.025 molar. That means the concentration of OH minus is equal to 0.025 molar. And then you get the pOH, we would say negative log of 0.025. And we get 1.6. So that's equal to our pOH. And 1.6 plus the pH is equal to 14. And we get that the pH is 12.4. Answer, pH. Answer, pOH. Okay? You're not getting what's going on, just, speak up, pause me, whatever. All right. 12 molar HCl. What's that going to mean? It's going to mean that 12 molar HCl equals 12 of H3O plus. Okay? So we're going to say negative log of 12. What's that going to be? This is an H plus concentration. That's going to be our pH. All right? And this is going to be a weird number, I think, because it's going to be negative. Yeah. So the pH is actually negative 1.08. That's okay. You should be suspicious if you have too many of those, but I may give you a couple. And then the OH then is equal to negative 1.08 plus pOH is 14. Add that to both sides. pOH is equal to 15. Answer. Okay? Alright, so what's going to happen with this guy? This one's worked exactly the same way. It's going to donate 1 hydrogen for each mole here, so that's just going to be 6 is going to be the concentration of hydrogen in there. Alright, so D here, we're going to have what? Barium hydroxide is going to go to barium plus 2 OH minuses. So what is it? This is 1 to 2. So they give you 2.03 times 10 to the negative 2 times 2 is equal to 4.06 times 10 to the negative 2. And what is that? That's an OH concentration. So OH is equal to 4.6. All right. And then pOH is equal to the negative log of OH minus equal to the negative log 4.6 to 2. And we're going to put that in here. Negative log of 6. What do we get? All right, so our pOH is equal to 1.4. pH then is equal to what? 12.6. All right, and again, let's just try not doing something dumb, and I can tell you guys wailing in anguish because you're 12 hours behind me. Let's make sure that that's right. Negative 0.78 is what I got. I'm working 32. What am I working here? What did I say I was going to do? 31 and 33. Well, there's good problems here too. Some of them, yeah, that's just a specific example of what you're going to be asked to do here anyway. Okay, well, good. Some of those, that's how you do those. Sorry. So getting from here to here, what are we going to do? We are going to, all you do is to get from here to here. I mean, to do the opposite, you say 10 to the pH is equal to what? Okay, so in this case, that's equal to the H3O plus. And 10 to the pOH is equal to the concentration of OH minus. Okay? So what does that mean for these? It means that 10 to the 1 is equal to our H3O plus concentration. Okay, that's simple. And so that's equal to 10. Okay. 10 to the 3.5 is equal to our H3O plus. All right, so then correcting that into proper scientific notation is all it's asking you to do. So we say 10 to the, sorry, it's glare, man, sorry. 10 to the 3.5, that's going to tell you I'm sorry. Gosh. 10 to the negative pH, 10 to the negative that. So this is 10 to the negative 1, so that's equal to 0.1. 10 to the negative 3.5. I'm sorry, guys. I hope you caught that before I did. All right, so that's going to be equal to 3.1 times 10 to the negative third. Fourth. Struggling here. Struggle bus. All right. Literally, you're just putting that in your calculator right here. Okay. And then you're going 1, 2, 3, 4. That's in the negative fourth. All right. POH, 10 to the negative POH is what? Equal to this. And, okay, I'll actually do the whole problem on this one. It's asking you to get both of those. So, all right, so what do we got? 10 to the negative 10th is equal to all right, is equal to 1 times 10 to the negative 10th, duh. All right, and so to get the H3O plus, what do we need to know? We need to know the pH. Okay, so what do we say? We said the pH is 10. So POH is 10, so pH is equal to 4. So 10 to the negative fourth is equal to that. And that's already, we just added 1 times there. Okay, that's nice and straightforward. Let's look at this one though. All right. So probably the fastest way to solve these, the most foolproof, is 11.88 is the pH. Go ahead and solve for the POH. Okay. The POH is 14 minus this one, which is 2.12. All right, and then just take the 10 to the negative 11.88, 10 to the negative 2.12, and what is that rewritten in proper scientific notation? 10 to the negative 11.88, and that's 1.32 times 10 to the negative 12th is our concentration of H3O plus, and 10 to the negative 2.12 is equal to 7.6 times 10 to the negative 3. Okay? And that is how you solve those. You can go and check the rest of those or do that. And then 34 just mixes them all up. And you guys can work through those in class if you've got time. All right? Okay, so those are the basic sorts of problem solving that we're going to do. You're going to need to do anything that was covered on your homework. All right, so now we're out of that. Review scope of test materials. What we're going to do now, we're going to take about 5 minutes to do that. We've gone through most of that in previous chapters. You guys have, previous lectures on this chapter. Okay, so what have we had to do? You had a list of general properties, acids, and bases. Review that, be able to do it. Know what properties they have in common, just using your brain there. Okay. Know what oxyacids are, carboxylic acids, we talked about that. Know what mono, di, and triprotic are. and what happens. You need to know the 3 different acid-base theories. So you need to know them in detail, but we talked about what you needed to know on those. Okay. 13. You guys let me know if you need me to work through some of these. I think they're pretty straightforward. It donates a hydrogen. It is the acid, and then it forms its conjugate base. And then this is the base, and it forms its conjugate acid. Okay. And it's, check that out. I will not. I've got a lot going on everything else, and I just need y'all to let me know if you need help more than that on that. We've talked about it. We worked through it. He's got examples in here, so y'all just have to let me know. We will need to know none of that. Okay, yeah, so we'll probably have a good bit on calculating these things like we had for homework. So let me know if y'all are not understanding some of that. You'll probably have to do a number of these. Okay, so you really need to talk and understand, talk amongst yourselves about the relationship between these, because these are the inverse relationships. Okay, the 10 to the negative, and then the negative log. Okay, that's how you go back and forth between those. You need to know this relationship. You need to know this relationship. This times this is that. Don't subtract that over. That's not going to work. Okay? It's not going to give you the number you need. Okay. All right. So know all those relationships. Those are not going to be provided for you. This is straightforward enough that you guys need to be able to pack that away in your brain for later usage. Okay, then know the vocab. Know the vocab for titrations. What else did we underlined it? pH indicators. We just talked about that. A lot of problem working that we're really not doing a whole lot with. You need to know your pH scale generally, not things on it, but you know, well, yeah, you don't really need to know anything other than, 7 is neutral, and then below that's acid, and you remember that's base. That may be a couple of questions there. You need to know this rule about the stronger an acid, the weaker its conjugate base is. Page 304. I already said you need to know the definitions of acids and bases. Monoditriprotic. You need to know hydronium, what that is. Hydroxide, what that is. I think I said you needed to know these few acids right here because they are so common. Okay. You need to know what those are, including this. Boom, 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 boom. And their names. So I'll make a couple of note cards there. You got plenty of time to study for this test. And that's going to be a wrap on that. So where does that leave us? All right, so you guys owe me some. I think I've asked you to get me your test correction. So if you haven't done that, I think that's already too late, maybe. Then we've got lab reports that need to be revised and come on in. We said there's something that was on the May 7th. Maybe it was just that this test was going to be on May 7th. Whatever. That's going to be the test is on Tuesday, and then we will go right into review for the final. We will review all on the next Thursday as well, and then we'll have a work session. I can't remember that date either, but we'll have to talk via email. and then we will be taking the final when whenever it gets assigned by the school. Okay, so we've got test, and then immediately we'll start reviewing for the final. We'll have a full class review session, then we'll have a work session together for actually some face-to-face time, and then we'll have the final. You guys will be finito. All right, talked long enough. We'll talk soon, guys. Thanks.